Hello Collins Cobras, this is Mrs. Hernandez and I'm hosting your video today over dot plots and stem and leaf plots. Dot plots and stem and leaf plots are two more ways to visually represent a set of data. We're going to begin with dot plots. A dot plot is a visual display of data using a number line and dots to represent each data point. The data that repeats itself most is often the mode. In a dot plot, the mode is the tallest value. And a mathematical term that would describe the tallest value is called a peak. So we're going to create our own dot plot right now. It asks us to survey the classroom with this question to collect some data, but I've gone ahead and created a set of data for us to use since we're not together to create this together. So what we're going to do is take this table and we're going to turn it into tallies on our chart and then record it as a frequency so that we can create a dot plot using this blank number line down here. I'm going to check off the numbers as I tally them to keep track of what I've put on our tally marks. So we've got one person who answered that they have one screen in their home. Here's a person who said 5, 10, 15 is not on our table, so I'm going to add it. 7, 8, 9, 6, another 5, another 5, 4, another 5, 8, 4, 6, 7, 5, and 6. So we've represented all of the data in this chart on our table here with tallies. Now let's turn that into frequency. So 0 people said they have 0 screens. 1 person said they have 1 screen. 0 for 2, 0 for 3. 3 people said 4. 5 people said 5. 3 people said 6. 3 people said 7. 2 people said 8. 1 person said 9. 1 person said 10. And 1 person said 15. So now we need to take this blank number line and number it with the set of data that matches our table. And then for the number of, in the frequency column of our table, that's how many dots we're going to put above those numbers on the number line. So since we had a frequency of 0 for 0, we'll have 0 dots above it. 1 had a frequency of 1, so it needs 1 dot. We'll skip 2 and 3. And then 4 has a frequency of 3, so it needs 3 dots. 5 needs 5 dots. 6 needs 3 dots. 7 needs 3. 8 needs 2 dots. 9 needs 1. 10 needs 1. And 15 needs 1. So now that we've created our dot plot, we can see the distribution of the data, we can see the shape of the data, and that's one of the good uses of a dot plot. We can see the peak where the mode is 5, and we can see that we have an outlier here at 15. And we can also say there's a gap in the data here for 2 and 3. Okay, so we're going to move on to a dot plot that's already been created based on the measurements of iguanas, and we're going to analyze the dot plot for this set of information. So for the first thing we're looking for is the mean. And because I know I'm going to be looking for median and range and IQR also, I'm going to go ahead and take our data and put it in a list from least to greatest before we get started. So I only put 12 on the list one time and 13 on the list one time because they both only have one dot. But 14 needs to occur on our list 3 times. 15 twice. 16 3 times. 17 twice. 18 twice. And 19 once. So in order to find the mean, the first thing we want to do is add the total of all of these numbers, and we're going to get 234. And we want to divide it by the count, or the number of numbers in our list, which is 15. And we're going to get 15 and 6/10 as our answer. All right, now to find the range, we need the greatest number, and we want to subtract the lowest number. So our range is 7. For our median, we'll cross numbers off till we find the center. So here's our median of 16. Now for finding the IQR, we want to find the median of the lower half of the data and the median of the upper half of the data. Since our median was only one number, it will not be used in the lower half or the upper half. So there's the median of the lower half of the data. And here's the median of the upper half of the data. So for the IQR, we'll subtract those. And our IQR is 3. Okay, so let's move on to talking about stem and leaf plots. A stem and leaf plot displays large sets of data into a table with 2 parts. A stem, which is the first digit or sometimes digits used to group the data, and the leaf, or the remaining digit or digits used to show individual data pieces. Each piece of data is listed in a stem and leaf plot. So we're going to start here where we've got a list of data that represents some grades in Mr. Avery's history class. I'm going to begin by putting the data in order from least to greatest because our stems are always, our stem and leaf are always in order from least to greatest. So we're going to start with 68. Okay, so we're in order from least to greatest. Another thing that's important about stem and leaf, after we've made sure that we're organizing by least to greatest, is that there's a key for stem and leaf. We're working with 2-digit numbers. So we're going to say that 2 as a stem and 7 as a leaf has a meaning of 27. So if we were going to apply this key to the number 68, 6 would be our stem and 8 would be our leaf. Then we need a new stem for 70, and the leaf would be 0. 79 still has a stem of 7, but a leaf of 9. The next number would have a stem of 8 and a leaf of 5. And then we'd have a stem 8, leaf 7, and a leaf of 8, and another leaf of 8, and then for 89, we need a leaf of 9. So this would be 85, 87, 88, 88, and 89. And then we need a new stem for 92 and 93. The key will not always be the same, though. It will not always be that the stem is a digit in the tens place and the leaf is a digit in the ones place. In this set of data, which represents the lengths in meters of a toy car can travel, we're working with decimals. So when we create our key, 2-7 isn't going to mean 27 this time. This time it's going to make more sense for that to mean 2.7 or 2 7/10. And we again want to begin by putting our data in order from least to greatest. Okay, and then we'll start with our the least number in our data set, which is 2.1. So a stem of 1, a stem of 2, a leaf of 1. For 2.6, we're still going to use the stem of 2, but give it a leaf of 6. 2.8, we need a stem of 2, leaf 8. 2.9, still using the stem of 2, and adding a leaf of 9. Our next number is 3.1, so we need a new stem and 1 for a leaf. We've got 3.1 again, so we need another stem 3, leaf 1. For 3.5, we're still going to use 3 as our stem, and we'll add 5 as a leaf. And then when we get to 4.0, we'll need a new stem and a leaf of 0, and then another 4.0. Alright, so now that we've practiced creating our own stem and leaf plots, we are going to take a stem and leaf plot that has already been created and answer some questions about it. The first question says, the range in energy scores is 26 points. So to find the range, I want to find the greatest value, so I need to find my greatest stem and the leaf with that, which is 82. And the lowest value, so my smallest stem is 5, and the smallest leaf on that stem is 5, so 55. And I want to point out the key right here. It tells us that 5-5 means 55. So the stems are digits in the tens place, and the leaves are digits in the ones place. So we're going to find that the range is actually 27, not 26. So that was a false statement. It says a total of 13 homes were rated. To find the total number of homes, we would count the total number of leaves. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there was actually a total of 12, which makes that a false statement as well. Okay, the next statement says the median energy score is 66. So to find the median, we want to take our stem and leaf plot and create a list of data. So we've got 55, now 56, then 58, 59, and 59, then 64, and 67, then 70, and 71, and 73, 77, and then my last piece of data is 82. So we can use that to find the median. And the median is two numbers this time, so we need to add them. So we get 131, and then we want to take that and divide by 2. So we're going to get a median of 65.5, not 66. So we have another false statement there. And then the last statement says the mode home rating was 59. We know mode means most. So we want to look and see where we have the most repeats of stem and leaf. And here we've got 59 and 59. So we had two 59s on our list. It was the only number that was repeated. So that's a true statement. Okay, so we're still evaluating this stem and leaf plot with these questions down here. The number of homes rated between 50 to 60 accounts for more than blank of the homes. Well, we know that there were a total of 12 homes that were rated, so we can create a fraction. And if we want between 50 and 60, that's going to count anything that's 50 all the way up to 60. So that would be 1, so 55, 56, 58, 59, 59. So that's 5 out of 12. We could leave it as a fraction. We can also change it to a percent by dividing top in, bottom out, and we're going to get about 42% of the homes. And then our last statement says the number of homes rated greater than 70 accounts for about blank of the homes. Again, we're working with a total of 12 homes, and now we want to look for leaves that are greater than 70. We cannot include 70. 70 is not greater than 70, so we could use 71, 73, 77, and 82. So that's 1, 2, 3, 4. And then I see that that's an improper fraction because it can be simplified to 1/3. So we could say that it's 1/3 of the homes, or we also know that 1/3 is 33.3 repeating percent. I hope you have a fantastic day. Enjoy your whatever else you have planned, and please don't forget to do the practice page after this video.